Video is for homework 3. In this section, the necessary libraries and models are imported. Seed is determined for PyTorch's random number generator. This is used to obtain repeatable results. And class f1. This part is where the f1 model is defined in the init function. The parameters and weights of the model are defined. The forward function performs the forward pass operation, and class f2, def init and def forward, the same process is repeated for f2. And def train, the train function is where the model is trained. Model optimizer and data loader are taken as parameters. Training of the model continues until it reaches a certain accuracy rate. We have specified the accuracy value as 0.99 here because it is requested in the question. List to store training losses for each epoch, and this accuracy variable counter for the number of epochs, increment the epoch counter, initialize the total loss for the epoch, and initialize the total accuracy for the epoch. Iterate over the training data using TQDM. Zero out the gradients. Forward pass to obtain predictions, calculate the cross entropy loss, backward pass to compute gradients, and update the model parameters using the optimizer. Accumulate the loss for the current batch, and compute accuracy for the current batch. Calculate the average loss and accuracy for the epoch. Print the mean loss from epoch and accuracy for the current epoch. And append the mean loss to list of losses. Return the list of losses for epoch during training each epoch. And finally def main. The main function loads data, defines, trains and evaluates models. It also graphs the training loss. Load data, and f1 and f2 models are defined. The learning rate is determined and the models are trained. f1 and f2 models are trained using the train function, and the training results are stored in the results f1 and results f2 list. Each learning curve includes the average loss in each epoch. We pilot these two results into separate graphs. The red one represents the training loss of this f1 model. We can see the change at each epoch change. As the epoch increases, the loss decreases. so the model achieves better performance. Now the blue graph, F2 model training loss. This, like F1, achieves better performance as the epoch value increases, loss value decreased. And evaluate, both models are evaluated on the test set and the results are printed. This code block evaluates the performance of models F1 and F2 on the test dataset. Evaluation results are stored in the test variables test loss F1, test accuracy F1, test loss F2, test accuracy F2. These values reflect the successes and losses of both models in the set. No. We ran the code on my friend's computer because I received various errors while trying to run the code. So I'm going to open a screenshot of the output. These are results. I have comment for option C of the question. The wider and shallower F1 model has more parameters and achieves a slightly higher test accuracy compared to the narrower and deeper F2 model, which has fewer parameters and a slightly lower accuracy. And it's done.